Oh, okay, so it's recording. Okay, guys, I hope you're doing well. I'm going to share my screen or attempt to share my screen, and so that I can do this thing. I need to share this. Okay, so no, Milio is requesting. No? Okay. All right. So can you guys see the paper?
Yes, I can.
Okay. And then like you see the unit circle. Oops. We're good?
Yes.
Okay. So we're going to fill out this unit circle. So the unit circle is like a huge thing. We would usually like have you guys do that little quiz. I don't know if you read on the module about it. But we would want you to be able to recognize the different pieces of the unit circle. So I'm going to go around and just start by filling in the degrees and radians and how I would do that. So as you guys learned when you were graphing angles, like this is your initial side. So this is what we consider 0 degrees. And then you know that a whole circle is 360 degrees. So we can also call that 360. Okay. Sorry. Okay. All right. So then that being said, we would know that over here, this would be 180 degrees. And then we know that half of 180 would be 90 degrees. And then another 90 degrees down here would be 270 degrees. Okay. And then we can cut the 90 degrees in half. So half of 90 would be 45. And so that's this one in the middle. And so then we would add another 90 to, another 45 to 90 to make the 135. Add another 45 to the 180 to get the 225. And add another 45 to the 270 to get the 315 degrees. So those are the places that are halfway through, like halfway in the middle of the quadrants. So then we have, then we can count by 30 degrees. So notice that like these are split like into thirds here. So those are each 30 degrees. So we have this 30 degrees, then this guy is going to be the 60 degrees, another 30 degrees is 90, another 30 degrees is 120, 150, 180, and then we just kind of keep adding 30 degrees throughout the whole thing. And then we get to the 360. So that's the degree part of the unit circle. Okay, so the next part I'll look at are the radian measurements. So when we deal with the radian measurements, we're going to start again at 0. And one of the conversion factors that you guys used was that pi equals 180. So that means that this 180 degrees is going to be the same as pi. And then a full circle then is going to be 2 pi. So that idea of pi being like half, like a semicircle is really a big deal, okay? So if this semicircle is 1 pi, that means that this here is halfway through. So this is going to be pi over 2. So then this is half a pi, this is 1 full pi, and this is 1.5 pi. So 1.5 pi would be like 3 pi over 2. And then we'd add another half pi to get 4 pi over 2, which is like the 2 pi. Okay. So now let's cut the pi halves in half. And what's half of half? Well, half of half is a fourth. So that where we had that 45 degrees, that's going to be like pi over 4. So what we're going to do then is count by fourths. So this is like 1/4 pi. 2/4 pi would be pi over 2. Here's 3/4 pi. 4/4 pi would be just regular pi. Here we have 5/4 pi. 6/4 pi would be the 3 pi over 2. 7/4 pi. And then 8/4 is the 2 pi. So a lot of the way that I think about constructing the circle is really like counting those fractions and just kind of like adding it from there, okay? All right, so we counted by fourths to help us get those middle pieces in. So now what we're gonna do is we're going to deal with this guy here as far as the radian measurement is concerned. And so if this is 1/2 a pi here, I'm sorry that there's this delay, it's irritating, sorry. So if this is 1/2 a pi, and we said that there were 3 congruent pieces, that means that we want to cut this pi halves into thirds. So if you think about cutting pi halves into thirds, that would be like multiplying it by 1/3. That gives you pi 6. And so that's what we're going to count by for these, like the 30 degrees. We're going to count by pi 6. Okay. So here's 1 pi 6. This is 2 pi 6. Oops. This is 2 pi 6, but 2/6 reduces to pi over 3. Then we have 3 pi 6. 3 pi 6 is really pi over 2. Then we have 4 pi 6. Well, 4 pi 6 is really 2/3, so 2 pi over 3. Then we have 5 pi 6. And then 6 pi 6. And 6/6 is like 1. Next, we have 7 pi 6. And then 8 pi 6. But 8 pi 6 would reduce to 4 pi over 3. Now we have 9 pi 6. 9/6 reduces to 3 pi over 2. 10 pi 6. Okay, well, that reduces to 5 pi over 3. 11 pi 6 doesn't reduce. And then 12 pi 6 is the 2 pi. Okay, so that's kind of where those radian measurements come from. As far as that's concerned, notice some things I talk about in the patterns is that in these, we call these like critical angles, these critical points, like the pi 6. Notice that the ones that end in 6 are always super close to the axis, to the x-axis. The pi fourths are always right smack dab in the middle. And in the pi thirds, those are actually farther from the x-axis. Okay. All right, so that's kind of where the radian measurements come from. So now let's talk about the ordered pairs. So this is called the unit circle because what we try to say is that like this is 1 unit, like this has a length of 1. And so if a radius has a length of 1 and we wanted to try to make an ordered pair out of that, that means that we moved 1 on the x-axis, but notice we didn't move on the y at all. So that's going to be the ordered pair 1, 0. We know that in a circle, all radii are congruent. So that means that this also is a radius of 1. So that means that this point would be 0, 1. This radius would also be 1. So that's -1, 0. And this radius is 1 also, so that's going to be 0, -1. Okay, so those are the quadrantal angles. So quadrantal angles are basically when it lands exactly like on an axis. Okay, so things like 90 degrees, 180, 270. Those are 360. Those are considered quadrantal angles when they land exactly on one of the axes. Okay. Okay. So that being said, let's talk about the different triangles that are created as far as where these are from. So if we look, there is a right triangle that is formed here at this 30 degrees, okay? And again, this radius is 1, which means that we're going to have some different components to make that. And instead of just going through the big theory convoluted way, I want you to notice that here, which is longer, the X or the Y in this little one here? Notice that the X, you're having to travel way over here, and then the Y, you're just kind of going boop. And so in this case, the X coordinate is √3/2, and the Y coordinate ends up being 1/2, okay? It has to deal with the relationship of the 30, 60, 90 triangles that y'all learned in geometry and whatnot. But if you did take like, and I won't take the time to do it totally, but if you took that √3/2, that X coordinate, as one of the legs, and 1/2 as the Y coordinate, by the Pythagorean theorem, you would get that this would be a true statement. Okay, but essentially, like you have this 30-degree angle that's here, and then because of the relationships of the 30, 60, 90 triangle, then the X coordinate ends up being √3/2, the Y coordinate ends up being 1/2. Okay, so we have another triangle that's in here. This triangle is the one that has a 45-degree angle to it. And when there's a 45-degree angle, notice that the X and the Y are going to be exactly the same. And it turns out that the side lengths that you would need to make a hypotenuse of 1 here are √2/2 and √2/2. Okay. There's a third triangle, and this is the one related to the 60-degree angle. So this big thing is 60 degrees. And again, the hypotenuse has a length of 1, but notice this time that the X coordinate is smaller than the Y coordinate. It turns out that this is, the X coordinate is 1/2, and the Y coordinate is √3/2. And it's really that first quadrant of the unit circle that's going to be the most important for you to know, because these triangles exist in all of the different quadrants. Like right here, here's another pink triangle. That's its official name, by the way, the pink triangle. I'm kidding. Okay, so, but the only thing that changes then are the signs. So like here, I'm still going to have √3/2 and 1/2. We're moving √3/2 units on the X and 1/2 units on the Y to get to this point on the unit circle. But notice that because we moved to the left, that means that the X coordinate is negative. The Y coordinate is positive. Here's another pink triangle. That means that we're still going to have √3/2 and 1/2 as the X and Y coordinates. But notice that in the third quadrant, you're going left and down. So then both of those are going to be negative. And then again, over here in the fourth quadrant, so this, the critical point that's closest to the x-axis will always have a √3/2 for the x, a 1/2 for the y, and then it just changes by sign. Here in the fourth quadrant, x is positive and your y is negative. Okay, so then we can do that. I'm going to throw things. So then we can do that with all the other points also. So the ones in the middle, where we have the pi/4, that family, any of these in the middle are going to be √2/2, √2/2 that are in the middle. Okay, so all of those are going to have √2/2. Oh, to annotate, okay. Caleb, I don't know what I just agreed to. Okay. Okay. Okay, so sorry, we're changing the signs here. So then we're going to take, sorry, in quadrant 2, the x is negative and the y is positive. In quadrant 3, these are both negative. In quadrant 4, X is positive and Y is negative. And then we can do the same thing to these points here. So the ones that are part of the pi over 3, 60 degrees family always have 1 over 2 as the X and root 3 over 2 as the Y. And then again, it just changes by sign, depending on what quadrant you're in. Okay. So it's really just this first quadrant of the unit circle that's super important to know, and then you can apply that all over the circle, okay? I don't know if you guys saw the video about the hand trick, and I'll talk about evaluating in a sec too, but the hand trick is super fun too. You might not know it, but your hand is a quadrant, and you have the unit circle living on your hand. What I want you to do is pretend that my hand matches up with this quadrant exactly, and I know when it doesn't, but I want you to pretend that your pinky is 0 degrees. Then this is your 30 degrees or pi sixths. This is your 45 degrees or pi fourths. This is your 60 degrees or pi thirds. And then this is the 90 degrees. So see how you have that nice little quadrant there? I'm sure your hands are cuter than mine. Okay. But if you forget, and sometimes like if it's been a long summer and I forget things about the unit circle, this helps me out. You can tell what the points are going to be. Oh, my battery is running low. Can you give me 1 sec? Sorry. Sorry. So what you can do is to tell the points is like to fold your fingers in. So like if I forgot what the ordered pair was for the 30 degrees or pi over 6, I'm going to fold that in. And notice that I have 3 fingers up top and 1 finger on the bottom. Oh my gosh, look at this ordered pair. We've got 3 and then 1, just like our fingers. So you can kind of think about it as like root fingers over 2. So here, the x coordinate is root 3 over 2, comma, the y coordinate is 1 over 2, okay? Now try the same thing for the 45 degree pi over 4 family. Fold that in. So the x coordinate should be root 2 over 2, comma, root 2 over 2. Oh my gosh, there it is. Let's try it for 60 degrees or pi over 3. We'll fold in our 60 degrees pi over 3. So that means the ordered pair should be root 1 over 2. And remember, root 1 is 1. So root 1 over 2, comma, root 3 over 2. And there it is. So we can kind of see that the hand trick might help us if we forget like which one goes where. Okay. Okay, so now as far as evaluating goes, how we would evaluate these different pieces. So if we look, let's look at the pink triangle, for example. Notice that we said that in the pink triangle, that the x coordinate was, I'll draw the pink triangle over here, a little smaller. That the x coordinate was root 3 over 2, the y coordinate was 1 over 2, and the hypotenuse was 1. So if we think about this point right here, notice that to get this point, which we said was root 3 over 2, we took the adjacent over the hypotenuse. So notice that the adjacent is going to deal with our, the adjacent over hypotenuse is the cosine theta. We said that the y coordinate was the 1/2. Notice that the 1/2 is the opposite over the hypotenuse. So the y coordinate is always your sine theta. And so that's how we can evaluate this with the unit circle. So let's say in this problem that we wanted to evaluate the sine of 135. And to be honest, I would start by just using the unit circle to get used to it, and then you can try to use the patterns kind of as we go. All right, so this wants us to find the sine of 135. So to find the sine of 135, I can go on the unit circle to 135. Sorry. And then for the sine, that means I'm going to look at the y. So notice that the y coordinate is root 2 over 2. So the sine of 135 is root 2 over 2. That's it. So what about cosine of 210? So for cosine of 210, that means we could look for 210 on the unit circle. And we know that the cosine, we're going to look for the x coordinate. So if we look at 210, our x coordinate was negative root 3 over 2. That's it. But what about the tangent of 60? So the tangent of 60, we would look here. Oh, shoot, we didn't talk about what tangent was. Well, if you think about what tangent is, notice that tangent would be our opposite over our adjacent. And notice that our opposite was the sine of theta and the adjacent was cosine of theta. So anytime that we want to do the tangent of theta, what we do is we take the sine of theta over the cosine of theta, which essentially is going to be like the y coordinate over the x coordinate. Okay, so to find the tangent of 60, what we would do is we would take root 3 over 2 divided by 1 over 2. So for tangent, there's going to be a little simplification involved, but do you guys see how these are both over 2? So it's like those over 2's cancel, and then you're just left with root 3 over 1. And again, we're not going to leave it as root 3 over 1. We would just have that as root 3. Okay. So how about the sine of 11 pi 6? So the sine of 11 pi 6 means that we go to 11 pi 6 on our circle. Sine means we look at the y coordinate, which is negative 1/2. And that's our answer. Cosine of pi fourths means that we look at pi fourths. And cosine means we look at the x coordinate. So that's root 2 over 2. How about the tangent of 5 pi fourths? The tangent of 5 pi fourths will go to 5 pi fourths. And then tangent means that we're going to take the y coordinate, which is negative root 2 over 2, over the x coordinate, which is negative root 2 over 2. And those are exactly the same, aren't they? And so that's going to cancel to be positive 1. Then we have some, I think these are the quadrantal angles. So the sine of pi, again, what we would do is we'd look at pi. Sine means we'd look at the y coordinate. So that would be 0. Cosine of 0 means that we'd look at 0. Cosine means we'd look at x, which means that would just be 1. Tangent of 2 pi, here's our 2 pi. And again, tangent is going to be the y coordinate over the x coordinate. That would be 0 over 1. We do not leave it like that, kiddos. Reduce that to 0. And then the tangent of 270, we look at 270 degrees. And again, tangent we said was y over x. So we'd take negative 1 over 0. And that's a big uh-oh, right? We don't leave it like that. What we write that as is we write it as undefined, and which can just be the UND, okay? But that's how you can use your unit circle to evaluate. So I know right now what we did is we actually used the unit circle to do it, but we want to get to the point where you look at sine of 135 and you're not fishing around on the whole circle. So like where we want you guys to get to is we want you guys to think, okay, well, I know that 135 is halfway between. So I know that halfway between would be like the 45-degree angle. So, and I know that the sine would be the y coordinate. So that would be root 2 over 2. And in the second quadrant, the sine would be positive. Like that's kind of where we want you guys to get. Or like 210. Okay, I know that 210 is super close to the axis. So I know that it's going to be this ordered pair that's close to the axis. It's going to be a root 3 over 2 comma 1 over 2. And cosine means that I would want the root 3 over 2. In the third quadrant, cosine is negative, so I'd make that negative. Oh, I should talk to you about that too. So as far as like the signs, you could think about the X and Y signs, but also there's this thing, and I think Miss Oliveira talked about it in her video, but it's basically all students take calculus. Okay, so that idea of all students take calculus tells you what trig functions are positive in that quadrant. So notice quadrant 1 is the A quadrant, which means that all of the trig functions are positive in the first quadrant, right? Because everything's positive. In the second quadrant, notice we have the letter S. The letter S means that the sign of theta is going to be positive, which means that anytime you would take cosine or tangent, that's going to be negative. Of course, if sine is positive, then its reciprocal cosecant would also be positive, okay? So, but we're just talking about the three basic functions. So quadrant 3, notice I have a T here. The T means that tangent theta is positive and that all the others, so sine and cosine, would be negative. And the C in quadrant 4 means that the cosine theta is positive. Oops, let me separate that there. That cosine theta is positive, but the sine and tangent are negative. So that's another thing. So like for sine of 11 pi 6, for example, if I was evaluating that, not like being married to staring at the unit circle, I noticed that this is in the pi over 6 family. So the pi over 6 family is this family right here, the root 3 over 2 comma 1 over 2. And sine, I know I look at the y coordinate, which would be 1 over 2. And I know that 11 pi 6 is going to be really close to 2 pi, so that's going to be in the fourth quadrant. And in the fourth quadrant, cosine is the only thing that's positive, so I know then that the sign is negative. And I think that's about it. So the other thing that I talked about that I typed out to you guys as feedback for the homework is just the importance of thinking about the radian measurements, the fractions. Like if I were to graph, just for example, like let's say that a question was to graph, I don't know, like 7 pi over 3 or something like that, okay? Then what I would do is kind of turn that into a mixed number. So 3 goes into 7 twice with 1 left over. So I think about that as 2 1/3 pi. And so then if I'm drawing that, then I have my initial side here. And then just, I think 1 pi, 2 pi, and then I go 1/3 of the way. And again, like remember, this is 1 full pi here. But that would be how I would graph 2 1/3 pi. And again, we always have 3 parts, the initial side, the rotational arrow, and then the final side. But that's kind of what I was getting at with graphing those different pieces. Okay, I'm going to stop sharing this. How do I do that? Stop sharing. Okay. Okay. So that's kind of the unit circle in a nutshell. The type of questions that you guys would have, I think I put on there what I had used as like a practice unit circle quiz before, but that's kind of what you would want to fill out in 10 minutes. So we would like point to a certain thing, like we would have that labeled as letter D, and then you'd want to tell us what the degrees were. Or we'll have this as letter A, and we want you to tell us what the radians are. And then we have you evaluate. So you can kind of see what that would look like, okay? Do you guys have any questions? If so, you can unmute yourself and ask a question. Oh, is there something in the chat? My bad, I'm trying to figure out how to change my name. Oh, okay. It's fine, okay. I don't know who Milio is, but hi, okay. All right. Do you guys have any questions? Did that help? You're like, no. Okay, I'm sorry. It'd be so much better live if we could be together and I could point at things. But that's kind of it. Oh, hi, Majori. Okay. If you have a question, if you don't want to unmute, you can type it in the chat because I have that open finally. Okay. Real talkative group today. Okay. I'm teasing. Okay. I miss you guys. And if you come across something where you want me to, this was an experiment today. I don't know how it went. But if you come across something and you want to do like a little video help, then let me know and I can set something up with just you or maybe like with the whole class. The other thing I'm thinking about, and I'll put something out about it, is that I think I'm going to offer like office hours. So my office hours are technically from 10 to 11 on Tuesday and Thursday. And so I'm thinking that I'm going to put in a little link at 10 o'clock, like to start the office hours. And that if you want help on like a certain problem, then you can just click on that link and we can like, I can kind of help you like talk you through it instead of typing through it, just because sometimes that's a little easier. I can have my document camera set up and, I can, try to show you if you need help with things. But I think that's what I'm going to do for this week. And then hopefully that way people can turn in the assignments not on Friday at 11:59 p.m. Okay. But I'm happy you guys are doing them. It makes my day. What, Jacob?
I said, got him there.
I know. So, but I want to help you guys. If you guys have trouble, don't fake your way through it. Seriously, like, this is just a good opportunity for you guys to get the trig under your belt so that next year you're not waffling as much. Yes, they'll, start from scratch as it were, but I don't know how fast they're going to have to go through it. So, and then you can have the heads up. Okay. So I guess that's it. Oh, I went over my time by 5 minutes. I thought I could wrap it up in a half an hour. I had technical issues. Sorry, my husband's laughing at me. Okay. So you guys, I hope you guys have a great day. If you need anything, just reach out at any time, okay? And I miss you, and I hope you guys are well, okay?
Bye.
Have a great day.
Yeah.
Thanks.
You're welcome.
Thank you.